Good morning, class. It's Mr. Zimmerman, and today we're going to go ahead and take a deeper look into Formative 1 and explore some of the bigger ideas that you're supposed to be taking away at this benchmark. Let's go ahead and dive on in, shall we? All right, so number one. Basically, this is 3.1, and it's asking you, can you look at a graph and pull out information? The first one is asking us which one has the greatest rate of increase. And I want you to think about it as if it was acceleration. Which function has their pedal on the floor, causing it to increase at the greatest amount? So I'm going to go ahead and look at this from 0 to 6. And I'm looking at the initial values for a clear takeaway that's getting much bigger than the others. And you can see right here, this is the moment when this line starts taking away and increases the fastest. This turns out to be f of x. For the next part, which function is the greatest initial value? The initial value is the y-intercept, which is right over here. Which one has the greatest? Well, let's see which line this is connected. I go to the point at the very top, and I carefully follow my line. All right, that line is representing h of x. For this final part, I got to see which one has the greatest value at x equals 5. So I start out at x equals 5. And now I'm going to go ahead and see, hey, which line crosses x equals 5 at the greatest spot, the one on the top. The one on the top is blue, which is f of x. All right, this next part is standard 1.1 and 4.2. Standard 1.1 is, can you read a scenario and create a problem? 4.2 is, can you use that problem or equation to make a conclusion? So let's go ahead and dive in. So it's talking about half-life. Half-life, I know things are getting cut in half. I know half-life is 50%. And I know that this is going to be a decay problem because my percentage is getting smaller over and over. I can see that if I fill out this table, I repeatedly divide by 2. And I'm going to go ahead and I'm going to use 1 minus r. Now, when I use 1 minus r, I'm going to minus 50% in decimal form, and that's just going to turn out to be 0.5. So I'm going to use 0.5 to simplify my equation. C of t is equal to my starting amount, 64, times 0.5, and I'm going to raise it to t. Now I have to remember, it's not every minute. I want it to happen every 5 minutes, so I'm going to divide by 5. Now for the next one, I got to see, hey, can I use this formula effectively? If I plug in 60 and I plug it in, this is where I'm going to have to use a calculator app like Math 84. I'm going to do 60 divided by 5, which is 12. And I'm going to go ahead and plug that in, and I'm going to get C of 60 is equal to 0.015625, which basically is saying there's barely any in a system. If you're thinking about it in a penny, there's not a lot. This next one, depreciate. So I know immediately that's going to be 1 minus r, and it's a rate of 15. So I know 1 minus 0.15 is going to be 0.85. So I'm going to create my equation as the same way. Okay, it says v of t, and I need my starting amount. Starting amount always goes first, 27,000. Now I'm going to times it by my 1 minus r, which is 0.85, and then I'm going to raise it to time. Okay, my gets into a wreck in 2026. Well, when did we buy the car? 2019. So 2026 minus 2019 is going to be 7 years. Okay, I need to use my equation for 7. V of 7 is equal to 27,000 times 0.85 to the 7th power. V of 7 is going to turn out to be a check worth $8,655.58. Now, in this problem, if you did V of 2026, you would get a much larger value. And you got to just remember these equations we're using in t. Here, we're using it in years. And in number 2, we had it in minutes.